Hi everyone, this is Dr.Aravind Rajan, an associate professor at the Aeronautical Engineering department at the IARE Institute of Aeronautical Engineering. So in the last class, we were actually discussing what are aircraft systems and what is a system and a subsystem. So I'll just recapitulate it a bit for us so that we can continue in a smooth manner. A system is nothing but a group of systems. A system is a group of systems which can be further divided into subsystems. So we have seen an aircraft. An aircraft is a system of different subsystems which are at level, which are known as individual systems. Individual systems are airborne systems known as airframe system, mission system, and also you have navigation systems, so on. And each individual system actually have subsystems where we have uh, different parts of the individual system, which are known as integrated system. For example, airframe system consists of wings, which consist of fuel tank. Fuel tank is a subsystem of fuel systems, but fuel system is a subsystem of mission systems. So everything is actually integrated or interconnected. So each system can have different subsystems that can give inputs to another subsystem, or it can take output from another subsystem and give input to its concerned subsystem. That is what what we are seeing is generic form of a system. So please note the figure over here. Give a keen observation. So what is written is the aviation system environment. But when I say a generic form of a subsystem, example, we have inputs which process a function to give an output. Do you get me? So for example, I'm a pilot. I'm controlling the aircraft. So what I'm doing is I'm actually pulling back my stick to make a pull-up maneuver. When I want to make a pull-up maneuver, that means when I'm giving an input or from using the pull-up stick or any joystick right now. Nowadays it is not pull-up stick, it is joystick. What is happening is my input or my disturbance to the stick in general is actually giving an input to the fly-by-wire control system. The fly-by-wire control system will actually process my input and then give an output to the control systems which control my elevator at the end of the aircraft. I mean at the empennage. So that's what we are seeing. Meanwhile, the elevator, that means how much it has been moved, what is the angle, what is the pitch angle I'm getting, or what is the angle of attack that I'm having due to my pitch up maneuver is being given as a feedback to my system. So this is a lively example of a generic form of a system. So what I have is a generic form. Any kind of generic form of a system actually has inputs which will go through process function. There are a set of functions which process my input data, okay, and they give me outputs. As you can see, let us take a lively example, a day-to-day example. Your phone. So you want to nowadays everyone is having phone which can recognize thumbprint to unlock your phone. So you're actually unlocking your phone. Once your phone is unlocked, you're actually swiping up or swiping down, left or right to go up to a menu which you like. So what you're doing is you're actually giving an input. When you give a thumb impression, your thumb impression is being read by the biometric scanner, which is actually interpreting your input. And once your input has been interpreted, it is giving output. The output here is the silver lining. Your phone is getting unlocked. Your phone is unlocked right now. When your phone is unlocked, your feedback is nothing but your display that you can see, or a home menu. A home menu that you're seeing is actually your feedback. Just giving a small example, it is not the exact case. So this is just to understand. So a generic system is a form of a system where you have inputs that go through a set of process functions which process my input parameters, and these input parameters and the result of the process function is nothing but my output. So this set of input, process function and output is actually given me back to the input material as feedback. And I don't want you to get confused, but actually, if you give a keen notice to this figure, you can see that the feedback loop is actually being read as input. Okay, so that is what we have. which is in the aviation subsystem. The feedback loop can actually be considered as an input to a subsystem. Do you get me? So let us consider, let us move through forward. Here, for example, I have broken down the generic form of the subsystem. For example, here I have my input, where I have a demand, a sensor, and other kind of subsystems which give me inputs to my brain. For example, my demand is food. My sensor is neurons that tell me I'm feeling hungry. And other subsystems are health conditions, for example. So these actually are my energy which I'm getting from already that I've stored from the previous day, for example. So I have all these. When I'm feeling hungry, my sensor is actually giving me a small signal saying that I want to eat, have something. So that is what my function is, eating. I'm chewing my function. So once I'm chewing, I am actually digesting it. The digestion is nothing but the process. The digestion process is nothing but your function or process or control, whatever you have. For example, when you're eating, when you're digesting, if you have had any food that is high in carbohydrates or high oil content, you will actually become thirsty. You have this thirst sensation a lot. Okay, so what is that is nothing but local feedback. Your system is actually giving you a local feedback saying that I need more water to process the food. So you have more liquids. And at the end, what is happening is you have your waste products and you have your flight deck, in the sense you can talk, speak, flight deck, and other systems like you can have your movements. And these all are energy, the rest of energy, whatever you have, is actually being stored for the next day. So the energy that you are not wasting is actually being stored. That means that feedback loop, that energy which is being as an output, is actually considered as feedback loop, which is taken as input for your next day. So that is what you have here. So I have, that means my feedback can also be an input. So just imagine this for an aircraft. So you can see that an aircraft is a system. When I apply the generic form of a system to an aircraft, I need demand. Demand is passengers, flight passengers who are moving from, let us say, from Hyderabad to New Delhi. The passengers are moving from Hyderabad to New Delhi. Sensor is whatever you do first flight checks and everything is known as sensors. Example, I'm not literally translating everything. I'm just applying the generic form of a system to an aircraft. So when you see sensor, you say, okay, it is full. My baggage is full. My baggage handlers have told that everything is okay, fine. And I'm also having other systems which say, for example, fuel is ready, intact, and a pilot has given the green clearance at the level of the aircraft. Okay, so what will we do? We'll actually contact the traffic controller. Air traffic controller is nothing but other system who will give a control, or who will give the green signal to take a certain runway and head up in a certain direction, and which is actually, and you will have energy where you have your engines. So you switch on your engines, you pull up back, and you do taxiing, and once you are taxi and you get on the runway, you actually go to V1, V2 and climb velocity, and then you climb and you take off. You're done. So all these inputs are actually being processed by your aircraft, where you have local feedbacks. That means my tire pressure is this much, that one is feedbacks from all other systems. It is a small example. What I'm saying is, you can actually be, some people might say, oh, what you're saying is not good, but it is just an application. So I have outputs. Outputs are exhaust gases and everything. Next, you have flight desk. What is a flight desk? So flight desk is where you sit. That means it is a cabin. Once you are inside, all the functions, the pilot will make some announcements. Or you have the blinkers for your seat belt, and even please switch off your telephones and electronic equipment. Those kind of blinkers. That is actually a subsystem of electrical subsystems. Electrical subsystem. You get me? And you have another effectors. So whatever you have left, you'll actually be getting back into other input. So that is what you're having as a generic form of a subsystem. As I'm saying, I have already given you an example, but here I'm giving you some theoretical statements. So generic form of a system where you have different, as I said, we have different factors that influence the system. So when you see here, the first and major factor that influence any kind of system, you can take car, or even a bike, or even an aircraft, any mode of transportation, or even simple computers that we use in day-to-day life, or even mobile phones. So factors that influence the subsystem, the major factor is safety. So is it safe? If I board this aircraft, is it safe? An example, recently we have seen that Airbus 737 MAX 8 has undergone a lot of problems, and it has been not fit for service, and it was certified not fit for service by FAA for almost 1.5 to 2 years, because there was an issue with its avionics subsystem. I'll come to you. What was the problem? That is not the main point of discussion, but I'm saying safety. If at all, I know the information that this aircraft is not fit for flying, and if at all a company is actually operating this aircraft, I might ask my question when I'm booking my flight. Actually, you can see when I'm booking my tickets, you can see which flight are you about to board, or which flight you will be boarding. It says Airbus or Boeing. Right now, Airbus and Boeing are the only aircraft manufacturers that share around 56% of the market share in civil aviation industry. So safety is the first concern. So what will I do? I'll not board that aircraft. I'll rather check for some other aircraft, even though some other airline, even though I'll be paying more, but I'm mentally sure that this aircraft is in good hands. Do you get me? And next thing is integrity, and the other thing is availability. That is the third one. Fourth one is mission success, and fifth one is customer perception. What I'm saying is customer perception is actually linked to all the above: safety, integrity, availability, and mission success. All these are interlinked. So if the aircraft is not fit to fly, the customer perception will be, okay, I'm not going to choose this aircraft. That is actually interlinked. Okay, all these factors that influence any system will actually introduce redundancy. So redundancy is nothing but uh, I'd say some kind of error. For example, let us not get into the exact definition of redundancy. Right now, when being an aeronautical engineer myself, when I'm designing an aircraft system, I'll actually try to compensate between failures and ensure a certain degree of safe operation. I must compensate between failures, I must reduce failures and increase safety. So this is what I need to do, for which I'll be using dual redundant systems. So dual redundant systems are nothing but, for example, let us say you're writing your project thesis. When you're writing your project thesis, you are having actually you have one major document which is in your laptop. So to ensure that you'll not be missing your, or you will not be misplacing your project thesis, you'll be having a copy of a latest version of your thesis. So that is nothing but you are being redundant. So a dual redundant system is nothing but a copy of an exact system which has nothing to do with its master copy. In pictorial representation, you have here. If you see, you have demand, sensor, other inputs, and also feedback, which we have seen in previous slides. This is the same system, a generic form of a system. So you have demand, sensor, and everything. But if you give a keen observation, you have the same thing which is in the background. So that is nothing but you have a copy of your same system. Again, you are being redundant. It is always best to have a dual redundant system to avoid failures. For example, let me come back to Boeing 737 MAX 800. So Boeing 737 MAX 8 actually had a problem with its MCAS system. MCAS is an automatic flight control system, which is a part of avionics subsystems or mission systems, both of them. So what happened was, due to the misplacement or the change in position of engines over the wings, the aircraft was giving some pitch up movements, which was not in its nature. It was giving some pitch up movements. So to control these pitch up movements, Boeing came up with a system which will take inputs from its flight control systems or the mission systems such as data recorder or you have its avionics navigation systems. It will take inputs from there, and it will process those inputs, and it will give some output. The output is to control the pitch of the aircraft. Pitch of the aircraft is controlled by elevator. So that was the exact plan. The problem is, it actually had some problems with its input. So even though the aircraft was in exact flight level, good flight level, it actually came to know, it understood that the aircraft is actually pitching down, and it gave up a pitch up moment. So this pitch up moment, when it comes all of a sudden, the pilots actually didn't have clue of what is going on. They didn't have any clue. So they were actually trying some other issues instead of attacking the MCAS system. So what happened was, all of a sudden there was stall. Stall is nothing but loss of lift. Once the aircraft is stalled, you either you overcome stall by pitching down or giving up extra thrust. But in this case, that was not possible. So 2 aircrafts crashed in between a period of 6 months. The first one was Lion Air, an Indonesian-based airliners, and the second one was actually Ethiopian Air from Africa. 2 aircrafts crashed in a period of 6 months. So that actually made huge noise in the international aviation sector, and the Federal Aviation Authority had actually given an input or a circular stating that all Boeing 737 MAX 8 in service must be grounded. So they came to know, after further investigation, they came to know that the problem was with actually MCAS system. So if Boeing had considered other options, these could have been avoided. Do you get me? So this is what we have, what we call as redundant systems. So that's it for today. I'm going to finish this class using a generic form of a system. The next subsystems of aircraft systems, such as airframe, mission system, avionics and all, we'll be dealing in further classes. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.